And division of decimals, again, you could do this stuff on the calculator. So I'm not going to spend too much time on it to, kind of going through the process. If you were doing it by long division, it ends up being a little more complicated. But for instance, there are some fractions that many people kind of know offhand. For instance, 1 divided by 4, 1/4 is 0.25. If you were to look at why this is really where long division could come in handy. You would say, well, we're going to be taking 1 divided by 4. Remember, with long division, it's always backwards. It's part of the reason why I think people get confused when you start dealing with long division. In any case, 1 divided by 4 looks like this. Well, 4 doesn't go into 1 at all, so we're going to write a 0 there. And normally, I would I would use a remainder here. I would say, well, 0 with a remainder of 1, so it's 1/4. Okay, well, that's not very helpful. Instead, what I'm going to do is I'm going to say, okay, well, instead of thinking of this as 1, I'm going to think of it as 1.0. 1.0 is the exact same value as 1, 1 and 0/10. It's not anywhere off of 1, but what this does, if I kind of pretend that decimal place isn't there, when I'm doing this long division, I can say, well, 4 goes into 10 twice. And when I do my multiplication here, 2 times 4 is 8. Subtract that off, I get a 2. And normally I would drop something down here, but there's nothing else to drop down. So what I'm going to do is I'm just going to say, okay, well, instead of 1.0, how about 1.00? And then I can drop the 0 down. Okay, now 4 goes into 20 exactly 5 times. And I multiply that, subtract it off, and look, it actually came out exact. Now, the one thing I didn't do up here is that when I wrote this decimal, I should have actually put the decimal up top right above that as well. So you can see we end up getting 1 divided by 4 is 0.25. If you think I'm kind of making, or if you think like this was made up, or maybe it could have come out some other way, you could always division undoes multiplication, so you could always check it. You could say, okay, what happens when I do 4 times 0.25? And, well, ignoring my decimal place, 4 times 25 is 100, and then moving my decimal place 2 places back to stop ignoring the decimal, and you can see 4 times 0.25 is 1. So this is the number that I would multiply by 4 to get to 1, and that's what this question is asking. What number would I multiply by 4 to get 1? Alright, so this is an example of what's called a terminating decimal. This decimal stops going at some point. I ended up with when I did the long division here, I ended up with a 0, and I didn't have to keep adding parts on. However, not all decimals are terminating. Some of them are what we call repeating, something like this. Let's see how this looks with the long division. So 1 divided by 3, again, looks like this. I can't go into 3 doesn't go into 1 at all, so that doesn't help at all. So I'm instead going to think of it as 1.0. Well, 3 goes into 10 3 times, and 3 times 3 is 9. When I subtract that off, I get a 1. And I'm going to do the same thing I did up here. I'm going to tack on another 0, because 1.00 is the same thing as 1. Drop that down, and 3 goes into 10, well, 3 times. 3 times 3 is 9. Subtract that off, we get a 1. And, hey, I'll do it again. Drop down to 0, and you could probably see where this is going. This gets in a never-ending loop. It just keeps going on. And I should put my decimal place here, just like I did up there. Again, the decimal place occurs directly above where it was down below. So we get 0.33333333, and the symbol we use to denote that this is a repeating decimal, oftentimes we do a line over the top of whatever sequence repeats. So I could say the sequence repeats right here. This would be saying there's a bunch of 3s after this. I could have actually said 0.3 repeating like that. That's also saying the sequence of 3s repeat. Sometimes, I guess, I wonder, do I have? No, I don't. Okay. If you had something like this, 0.12121212, if that was the sequence that was repeating again and again, what you would want to do is you could say 0.12, and you do the line over both the 1 and the 2, and that indicates that both of those repeat. Alright, so in any case, now, when I remember a while ago I was debating with one of my friends why this number it does make sense. It is finite. It's actually labeled somewhere on your real number line. So if you have 1 here, sorry, 0 here and 1 here, 1/3, you know, should be 1/3 of the way between them. But 0.3 is a little to the left of that. 0.4 is going to be a little to the right of that. So this is 0.3, 0.4. This 0.3 repeating should actually lie in between them. So you could even zoom in on this. You could say, okay, what happens with 0.33 and 0.34? So if I was to zoom in on this, we have 0.33 somewhere in there. We have 0.34 just to the right of that, and 0.33 repeating is going to be directly between those. This number, even though the decimals keep going on forever, it is definitely located. There is a very specific location of that number, and like I said, it's 1/3 of the way between 0 and 1. All right. In any case, how about 3/8? This is one that might not be as commonly known, but we can do the same sort of thing. We could do 3 divided by 8. Well, 8 doesn't go into 3 at all, so I'll go ahead and give a decimal there. Give a 0 there. 8 goes into 30 3 times. 3 times 8 is 24. Subtract that off, we get a 6. Drop down another 0. 8 goes into 60. Well, let's see, you can get 56, right? That's 8 times 7. So that gives us 56. We subtract that off, drop down yet another 0. I'm not worried about there being any sort of repeating decimals here. It actually happens, you get those repeating decimals when the amount that's subtracted off, your kind of remainder, if you were to stop then, if that actually ever repeats, that's how you end up getting a repeating decimal. But that hasn't happened yet. We got a 6, and we now have a 4. Let's see, 8 goes into 40 exactly 5 times, so it looks like we actually get 0.375. And of course, you could check these on your calculator, and frankly, if I was doing the work for one of these, I would recommend, I would recommend for you to just go ahead and do this stuff on the calculator. 1 divided by 4, we just type it in exactly as it's written. Now, when we're talking about these fractions, it's always the number on top divided by the one on the bottom. You never want to swap those around. And again, with this, it's 3 divided by 8. So 1 divided by 4, you can see we get 0.25. That's what we got up here. That's the 0.25. 1 divided by 3 is 0.3 repeating. This calculator does end up rounding it, and you can see if we occasionally, if you did something like 2 divided by 3, you can actually really tell that this is rounding, because this is actually 0.6 repeating. So we'd go 6s for a while, and at some point the calculator says, okay, I'm going to round this. This is a 6, the next digit's a 6. It's going to round this up by changing that to a 7 and just cutting off everything that goes after it. And the reason for that is because the calculator doesn't know how to deal with infinitely many decimal places. It has a finite amount of memory that it uses, and that's it has to make allowances for that. And then 3/8, the last one we said, 0.375, and you can see that's exactly what we got here.